Okay, so now that we know how to determine if two matrices are equal, let's consider how we can perform arithmetic with matrices. So how can we do addition and subtraction? Addition and subtraction for two matrices is going to be done by adding or subtracting the corresponding terms of the matrices. Two matrices may be combined with addition or subtraction if and only if they are the same size. Since addition and subtraction are done entry by entry, we have to make sure that the two matrices have the same number of entries and also that they're organized in the same way. So I can't add a 2 by 2 matrix with a 2 by 3 matrix because they're not the same size. Alright, so let's take a look at the two matrices that we've been given here in this example. We'd like to compute A minus B and the matrix A plus B. So let's go ahead and do the subtraction first. A minus B, in the first position, we will take the entry from the first position of A, which is 3, and we will subtract the entry from the first position of B. So this will be our first position in this new matrix A minus B. If we want the entry in row 1, column 2, we'll take the entry from A in row 1, column 2, and we subtract from it the entry in B from row 1, column 2. And we'll continue like this throughout the whole matrix. So row 2, column 1 was -1 minus the same entry, row 2, column 1 from matrix B. And last but not least, we have row 2, column 2 from A minus row 2, column 2 from B. And so let's see, 3 minus 0 gives us 3, 4 minus -4 would give us a positive 8, -1 minus 3 gives us -4, and 2 minus a -1 gives us positive 3. So A minus B is equal to the matrix 3, 8, -4, and positive 3. Okay. Addition is going to work in much the same way. So let's see if we want to do A plus B. We will start with the 1, 1 position in A, and we will add to it the 1, 1 position in B. So we will have 3 plus 0. Then we will have row 1, column 2 from A, which is 4, plus row 1, column 2 from B. So now we have the same thing. We're just moving along, this time with addition. So -1 and 3 would be our row 2, column 1, and row 2, column 2 will be 2 plus -1. So adding each of these terms together to get the individual entries, we have 3, 0, positive 2, and positive 1. So the matrix A plus B is 3, 0, 2, and 1. So it's pretty simple. You just have to make sure you keep track which term you're currently adding or subtracting on. Also note that with subtraction, the order does matter, because if we were doing B minus A, then all of the numbers that we have, they should be the opposite value. So instead of a 3, we would have had a -3. So the order matters for subtraction. Now here are some questions to think about. Is matrix addition commutative? That means, does the order of addition matter? And the answer is matrix addition is commutative. So that means that it doesn't matter if you add A plus B or B plus A. And let's think about that with this example. If I swapped the order that I was adding all of my terms, then that doesn't change the final result. That's not the case with subtraction, though. If you switch the order, then you'll get the opposite sign. So addition is commutative, but not subtraction. Is matrix addition associative? Meaning, if you're doing A plus B, and then you add the matrix C, is that any different than adding matrices B and C, and then adding the matrix A? And the answer is yes, it is associative. So it does not matter which order you add things. And that's because standard addition is associative. So if you want to add 1 plus 2 plus 3, you could add the 1 and the 2 and then add 3, Or you could add the 2 and the 3 and then add the 1, and you still get the same number either way. So since standard addition is associative, so is matrix addition. Now, a perhaps more interesting question, is there a matrix that acts like 0? So is there a matrix that if you add it to any other matrix, it will give you back exactly the matrix that you started with? And the answer is yes, there is a matrix that acts like 0. Since in matrix addition, you add element by element, so term by term, if we want each term to remain unchanged, then the matrix that we would like to add to it is a matrix that's entirely 0. So depending on the size of your matrix, you can have a 0 matrix of any size. So there is no one 0 matrix. So if you're dealing with a 2 by 3 matrix, then you can make a 2 by 3 matrix of all zeros. If we have a 3 by 4 matrix, then the 0 matrix would look like the one we have here. So that's something that's interesting to think about. Addition is commutative and associative, and we have the idea of 0 with matrices.